Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Fischer esterification mechanism under acid catalysis, H2SO4. The reaction is between trifluoroacetic acid, CF3CuO, and isopropanol, CH3CH, or CH3, to give the ester CF3CuOH, CH3, 2 and water. Step-by-step mechanism. 1. Protonation of the carbonyl oxygen of CF3CuO by H2SO4 gives the activated acylium-like species, CF3C, is equal to OH plus O. This is option A, a valid intermediate, the protonated carbonyl. 2. Nucleophilic attack by the oxygen of isopropanol on the electrophilic carbonyl carbon produces a tetrahedral intermediate with 4 groups on the central carbon, CF3, OH, from original acid, OH, protonated from attack, then deprotonated or still plus OH2 at oxygen, and OCH, CH3, 2. The neutral tetrahedral intermediate with 2 OH groups and 1 OCH, CH3, 2 is option B, a valid intermediate. 3. Protonation of 1 OH group gives the plus OH to leaving group, yielding the intermediate in option C, also a valid intermediate, which then loses water to regenerate a protonated ester, completing the mechanism. 4. Option B shows a tetrahedral intermediate bearing a negatively charged oxygen, O, and OCH, CH3, 2 group, and an OH group. Under acidic conditions, H2SO4, formation of a negatively charged oxyanion intermediate is highly unfavorable. This would be characteristic of base-catalyzed or uncatalyzed nucleophilic acyl substitution conditions, not acid-catalyzed esterification. In the acid-catalyzed mechanism, all intermediates are neutral or positively charged, no anionic, O intermediates are formed. Why option B is not an intermediate? In acid-catalyzed esterification, the mechanism never involves a negatively charged tetrahedral intermediate. The oxyanion shown in B would only arise in base-catalyzed conditions. Under H2SO4 catalysis, the oxygen atoms remain protonated or neutral throughout the mechanism. Therefore, the correct answer is B. Therefore, the correct answer is option B.